Good morning, good afternoon, and good evening, everybody. Welcome to 7C's Tech Week and to our today's online session with the topic Nautilus S-100 ECDIS Kernel SDK. First of all, I would like to thank you for joining our nice online event, which is a continuation of our S-100 camp that already started 2 days ago. The session from yesterday, behind the scenes inside the S-100 technicalities, is a perfect fundament, but not a precondition for today. So, who am I? My name is Stefan Gonnermann, and I will be your host for this session. I am responsible for the 7C's sales support department, and I'm with 7C's for nearly 15 years now. I'm happy to guide you through this interesting event today and to assist our experts with incoming questions. So, what to expect from the next, let's say, 56 minutes? We will give you an introduction of our new S-100 kernel SDK called Nautilus. You will learn some details about spatial data model, coordinate reference systems, and of course, our Nautilus ECDIS Kernel SDK. Who would be better suited to bring some light into this topic than the current product manager of the Nautilus SDK and our today's expert, Mr. Holger Bocin. Welcome, Holger. He's already part of the 7C's furniture and an accredited institution when it comes to S-100. Holger graduated as a navigation officer and is for almost 25 years at 7C's. Most of the time he was busy with software development and is one of the reasons for the success and customer satisfaction with regard to the EC 2007 kernel, ECDIS Designer, and Nautilus. Since 1996, he's involved in the standardization of hydrographic data, S57, S100, and an expert for data modeling, coordinate reference systems, and ISO encapsulation. Our co-expert for today is Friedhelm Mogart-Kegeler, and responsible for the technical execution of this webinar is Pavel Kapliszewski. So this webinar will be recorded and later available on our YouTube channel. All of you will be notified by email accordingly. If you have any questions during the session, please feel free to address them in the question section of this webinar tool right away. We will try to answer as much questions as possible at the end of the webinar. Remaining questions will be handled after the session by email. Well, let's stop sharing boring behavior rules and start with the interesting part of this session. Please stop smoking and fasten your seat belts. Holger, the stage is yours.
So good morning to everybody from Holger. We have the pleasure together to see some informations about our new masterpiece of software, the Nautilus ECDIS kernel. But before we go to the details on the software itself or information on the software itself, we have to look at some other things. The first sentence came into my mind when I thought, oh, why we have this standard and why it's useful. And I say it's maybe not useful if it's not implemented, because if a standard is not implemented, this is just a bunch of ideas. They might be good, but nobody has any advantage from just ideas. A geospatial standard, and that's the standard we're talking about here, if this should have some advantage or should be coming into praxis, two things must happen. First of all, a data standard without data, it's an empty container. So we need data, and this data must be conformal. And we know from the past that this is quite a time-consuming exercise, and it takes, because data producers must be aware on the standard, tools must be available, and it must following in their production scheme and so on. So this is one of the preconditions that the standard is a success. The other precondition is this there must be software or systems which uses this data, because the data on its own are also useless. So we have to have these two things to bring a standard into practice. Of course, the standard itself should be complete and consistent, which sounds easy, but as you learned the days before, this standard S-100 is quite a complex and comprehensive document, which more than 700 pages. So to produce a standard on this size without any inconsistency is a not possible thing. But during the maintenance on lifetime of this standard, it will become better and better. Many of those inconsistencies only will be detected when this standard is implemented, because from the just writing the standard and from the theoretical view to that standard, you will not find all the inconsistency. But if you're starting to implement this standard very, very quick, you will see, oh, what they mean here, why it's written on another way, on another place in the standard in a different way. So what is the correct thing? Those things, of course, will happen. But for that, standards have a maintenance procedure or a maintenance section, and they can be then corrected. Okay, now let's see a practical problem which might arise when we implementing the standard. And the problem, I was asking myself which problem I should present you, and I had two came to my mind. The first was I can talk to you about projection, map projection, because this is one of my favorite things to do. And I say, okay, I only have 45 minutes for my presentation. If I start talking projection, we need much longer. So, so I could then say we need something else. Another very interesting topic then comes to my mind is the interpolation of line geometry. And I think that will just fit in. Okay. To understand the problem, we have to go back to the standard and have again a look to some of the data models. You remember S-100 is called the Universal Hydrography Data Model, and everything in this standard is about models. So we will see a small part of the spatial data model, and we will see we have also to talk about coordinate reference systems to understand the problem of line interpolation. Let's start with the coordinate reference system. Since this is a geographic standard, our locations of the feature objects are referenced to the surface of our planet. And for that, the coordinates are in a geographic coordinate system, which is based on an ellipsoidal coordinate system. That means the surface which is used for this coordinate of the Earth is a rotation ellipsoid. And we have two coordinates, as you really might know: the latitude, which is the angle between the normal through a point and the equatorial plane. You should mention in the little, or you should have a look to the little picture here, and you see that the angle, actually the red line from the point to the equatorial plane, does not go to the center of the Earth. It goes somewhere in the equatorial plane, but this line is perpendicular to the surface of the ellipsoid. And then we have the longitude, which is the angle between a reference meridian, usually the Greenwich meridian, but other things are possible, and the meridian which passes through that point. So this is well-known coordinate system we will use. And we use that in a geographic coordinate reference system. So reference, what's the difference between a coordinate reference system and the coordinate system? The coordinate system is just the system where the coordinates are stored. So there we have axes and they define what are the coordinates, so latitude, longitude, those things. And then on the coordinate reference system here, we have to add also a geodetic datum to that reference system, which consists of two things. First is it defines a spheroid, really defining the shape of the Earth. That means the dimension. What are the major and the minor semi-axes of that ellipsoid? And we have to define a reference meridian. That things together makes a geodetic datum. Luckily, in the last time, many coordinate reference system using now the same geodetic datum, so that the topic of datum transformation is not so critical anymore. Also, it still exists, and there's a lot of coordinate floating around which referring to different datum, and then this coordinate datum transformation is a topic again. Okay, we have sometimes coordinates which are not referring to a geographic coordinate reference system. They're referring to a projected coordinate reference system. That means this coordinate reference system is based on a geographic ones, taking the datum from there, but it defines in addition a projection method. A projection method is a mathematical algorithm which turns coordinates from latitude, longitude from an ellipsoidal coordinate system into a Cartesian coordinate system. A Cartesian coordinate system is a coordinate system, and here is a two-dimensional one in the plane, and the two axes are perpendicular to each other. So, as an example, many of this coordinate system using the axis northing and easting. Although I saw also some others like southing and westing. And the projection method only describes the algorithm, but to create a coordinate reference system, you have to parameterize this algorithm. You have to give parameters which makes the projection method in a projection. So this parameters can be the central meridian, latitude of true scale, those things, scaling factors. That depends on the method itself. So now we know what coordinates we have in our standard. We have coordinates on the surface of the spheroid, or we have coordinates in the plane, which refers to some coordinates on the spheroid. Now, the next thing, we will here see a small part of the spatial model of S-100. And this is the part which defines line geometry. So we see the class here. I don't know if you can see my mouse. Here, the orientable curve is the base class. It's an abstract class. And then we have two subclasses. Here, the curve class, and here, the composite curve class. The composite curve class consists of other curves, so we can make hierarchies of curves. The curve class here itself contains, as a composition, curve segments. And this is the part where the geometry is defined, where the coordinates are. You see two members in that class, the control points, which are coordinates, and we have an interpolation method. So the control points, each segment of the curve defines its own set of control points. So we can have more than one segment for a curve. And the question is, what is between these points? The control points are part of the geometry, but what is between these points? And the answer is, there are also points, but they are implicitly defined by a mathematical concept called interpolation. What does this mean? I give you some examples. Here we see 4 examples for interpolation methods, you can see the points and you can see what is between these points. In the first example, we have linear interpolation. That's relatively easy, and most people thinking about this when they thinking about interpolation, but that's not all. Another method is this circular 3 points interpolation, which means if you have 3 control points, they're defining unambiguously a circle. The next one is an elliptical interpolation. That means our interpolated points between the control points should form the part or the arc of an ellipse. In this case, it is an axis parallel ellipse, and we need 4 points to define it. If it's an arbitrary ellipse, then we need even 5. And the last example is a polynomial spline, or it can be any other splines or different types of spline. We have the control points, and then you have well-defined mathematical concepts to calculate the points between them. But you see, especially on the last 3 things, that is something what you might not think of when you think about interpolation. You think, Joe, I will just draw a line from one point to another point, and that's it. But that's not what the data producer want to be modeled. For instance, the spline interpolation, which we add to the standard in in the last version, I think, the last edition, comes there because we had a request from the metrological community, and they say we want to model isobars, the lines which you know from the weather charts, and they should be modeled as splines so that they should not have sharp corners, because sharp corners on isobars have a special meaning, and that's maybe not what we want. We want to have smooth curves. So these are examples of interpolation which is well defined in the Cartesian coordinate space. I don't want to show you how well this is defined, so I was tempted to give you now all the formulas for this interpolation, but then I said that would be too exciting, and we want to not to blow your head apart. So that's why I stay away from showing you any formula. But I'll show you 2 more examples of interpolation, because some of the interpolations are defined directly on a curved space on this surface of our spheroid or ellipsoid, which can be used, both words can be used for the same thing. And there we have 2 interpolation methods. One is the orthodrome. Some may know this as a great circle. Also, the correct term for this thing is the geodesic, which is defined as the shortest path between 2 points, especially in a curved space. This can be the surface of a spheroid, but it's also true for the space-time continuum in the relativity theory of Einstein. That is the same mathematics. And then we have the loxodrome, which is also known as the ramp line. And this is a path between 2 points, which crosses all the meridian at the same angle. And this interpolation method has a big or long history in navigation, because this is actually the path most of the ships traveling, because their bearing on the compass will be this angle to the meridians. I think now we're coming to a really interesting question. What is a straight line? And actually, I want to ask you what it is. And we have prepared some little poll to give you some of the options. And I kindly ask you now to try to answer it, and don't take it too serious. Okay. Half of you have already voted. Okay. Yeah, very interesting answers. The favorite of you is this the path of the shortest distance between 2 points. And to be honest, the question was not quite correct because I just asking for a straight line, but I don't ask what is a straight line in which reference system. But of course, whoops, the question actually is good. And it comes to the next question. And then this question will be how we can execute an interpolation in the curved space where the mathematics are defined in the Cartesian space. So a straight line in the plane, in the Cartesian coordinate space, that's relatively easy. We all learned that in school, how to calculate it. Some of you might remember. And but this straight line, a straight line on the surface of the spheroid, it's really not defined at all. So we have to do some trick. And I show you how it can be. If we cannot calculate the interpolation in the curved space, then we just transform the coordinates to the Cartesian space, do the calculation, which is relatively easy, and then we transform the results back to our curved space. Which brings me to the next question. What is the transformation we use? And we have seen that projection can do this task. And the proper projection for doing this is called the azimuthal equidistance projection. I give you the little image here on how this looks. And this is a projection where each point in the projected plane, which has the same distance to the center of that projection, has also the same distance on the curved space. So the mathematical concept is called the exponential map, but you can forget that. What you see is the concept of interpolation in general is not so difficult to understand, but it can be hard if someone wants to execute it. Theory sometimes is easy, implementation, it's tricky. So why we have seen this? Because our topic was about a piece of software. And now we had this big excursus to to models and coordinates and mathematics, and so yeah. But we learn from that example that even a simple line can be quite complicated when we're looking into the details, and if we want to try to draw it somewhere or to calculate the points on that line. But don't worry, you have not to deal with these details yourself. We can help you. This kind of details will be handled by software and then remove the burden from your shoulders. And the Nautilus SDK kernel is exactly such a kind of software. It hides the difficulties from the client, from the user, and makes writing an S-100 compliant application a piece of cake. So let's look what the actual SDK is. It is a software development kit. Some of you which are a little bit more familiar with software development might say that this is a library. some of you have also seen some those things like DLLs. In fact, if it's for Windows, then it isn't DLL. And with this software development kit, someone can develop applications that have a need to view or access digital data, especially in the hydrographic domain, but not only. This includes the type of applications someone can write with this SDK. This includes regulated ECDIS systems, or ECDIS systems which are a subject of type approval. Also inland ECDIS systems or chart radar systems. You can also do ECS, electronic chart systems, which are not regulated, and portable pilot units. It's another type of navigation application, which running usually on a small mobile computer, and the pilots take this on board and to do their job. Vectis is another application which can be done with this SDK, the warship ECDIS, so the military part of the hydrographic world. Situation awareness centers is another example. I could do this list, could be longer and longer. Vessel traffic systems, all of those applications where you need access to geospatial data, and especially when you want also to show them. What's very important to know is that our internal SENC data model, I have to explain what a SENC is. The SENC is our internal format. Also, the term refers, or the abbreviation returns to system ENCs. This is not limited to ENCs, but this is a term which comes up over the years in standardization. It is now used. Also, the actual name of it does not really describe what it is for. It is more the general internal storage format of geospatial data, but I don't know how the abbreviation for that would be. And I think it's also too late to change those abbreviations now, because everyone is talking about SENC. But the data model for that is 100% compliant to the S-100 general feature model and the S-100 spatial model. And that's very important. That's actually the most important thing we have with the ECDIS Kernel. That means if you're going to implement an application now, it will be, in all cases, ready to use S-100 compliant data. I give you now some highlights of our SDK, what we can do, or what the user can do with the SDK. First in the list is chart handling. So what we can do with charts, we can, before we showing any data or portray them or accessing them, we have to import them into our systems. And this is supported with high-level functions in the SDK. So there's a function in that SDK where you can give an exchange set, S57 exchange set or the S100 exchange set. You can give that to the chart handling function, and automatically it will decrypt the data if it's encrypted. It will import, read the ISO 8211 or GML files, converted it to our own format, stores in the right direction, updating our internal catalogs. All those things goes behind the scenes. So you have not to deal with that. Just calling one function and getting some information back if things getting successful or errors happens, which can always happen, because here we're talking about data. Errors, I mean no software errors, I mean data errors. So, data not conformal. So then we will inform the user to about what happens. So he can then going with this information to the data provider and say, hey, you give me data which are not conformal, I cannot import them. Something like this. The next big highlight or point here is the chart display. So the chart display is one of the most demanding things in that SDK. People want to see geographic data. They just want not only to load them in the system and using them in some secret way, they want to present them. So for that, you have to select what are the actual data sets which I want to see for a certain area which I'm interested in. But this selection is also done by the SDK. So the user of the SDK has not to manually select or by some other ways what are the data I want to show you. This goes automatically. You just say, I want to see this data product or this data product, and then the SDK will find out what are the data sets available in that area and load them into the system automatically before portraying. It will be based on position and scale. Another aspect of chart display, which I have not mentioned here in this slide, but I want to tell you, is a map must be projected because all our data are geographic, and the geographic we learned we cannot show geographic coordinates directly onto an image. So we have to convert them into some image coordinates, and one part of this conversion is the projection, also known as a map projection. And a very difficult task is to choose the right map projections. So there are so many, and there's not a single one which can be used in all cases. That is an exercise I have learned. And then the question is which one we should choose from that big number of, I don't know, 30 or more projection. And we saw this is too difficult for the user of the SDK. Also, he can choose it, but we also offer a mode that automatically a proper projection is chosen for the chart display. And it's not a secret to tell you what we use. So our default projection is the Mercator projection. It's not a surprise because it has this nice property that loxodrome lines are straight lines. And when I say straight lines, I mean a straight line in Cartesian coordinate space. And but this has also some drawbacks or some problems, this projection. You might know that from seeing so many maps in the internet now, where you see that in the polar areas, especially like the island of Greenland, having a larger area than the whole continent of Africa, which is actually not true. And that comes from the nature of that projection. It's a cylindrical projection, and it's not possible. It's not works very well in the polar areas, and even the pole itself cannot be projected at all. So if we come to that areas, we need something else, and what we choose them is the stereographic projection. So we choose this stereographic projection always if we have polar areas in the display. Okay, now I'm starting to talk about projections, and I have to stop that, otherwise I will run out of time here. More highlights. The chart object handling. We're having access to all details of all elements of the data sets. So all what we have seen in the data models, all the spatial models, down to the coordinates. We can go to each attribute. Every little piece of information is accessible by the SDK. But we can also manipulate those data. So the SDK allows create your own object, to delete objects, to modify objects. And we have also a nice interface for querying the data without going to all the little details of the model. So there's a nice query class in this SDK where you just passing some filters to it, and it runs through a data set and investigate all the objects they find, and yeah, and checking it against this filter. And the one which passes the filter will be reported to the caller, and the one which are not passed, of course, it will not be reported. Okay, the next thing is this flexible data query. That's actually what I've talked about. And the good thing is the filters are an extensible interface. So we're using technology here. We will see that soon, which is called the object-oriented program paradigm, and it allows you to subclass or inherit from classes or interfaces to create your own filters. So if the filters we provide, and we provide quite a number of filters, did not fit your requirements, you can also write your own filter. So that's, on the one hand, we have high-level functions, but we also have the possibility that someone can customize the SDK to his very, very special needs, which we couldn't foresee when we wrote this stuff, because sometimes customers have very special requirements. We support S57, we support S-100, and also the vector product format, so we can read data which are based on the standards. We have a functionality anti-grounding inside, so that means as automatic can run tests on a small or not so small area, which is defined by a polygon, and finding hazards to navigation within this area. This can be wrecks, areas with not sufficient depths, but also other things you want to avoid, not only anti-grounding. For instance, it can give you other hazards like aids to navigation. Also, it's called aids to navigation. They help you, but if you hit those things with your ship, it's also not very useful. So that's why those things can also be detected. And we're having a section in the SDK dealing with routes. So that's especially important if you write an navigation application. So then where a ship goes along a planned route. So we have elements there for planning. We have elements there for doing calculations on the route, but also monitoring the route. So if someone then uses this route, we can calculate the cross-track distance to that route. And we have also functionality for checking that route against again hazards which might be close to that route. And we can save that route and load that from the now new standard for routes, the so-called RTZ format. So we have a little bit more highlights here. We support in this SDK also weather overlays. So we can read GRIP 1 and GRIP 2 data. GRIP is a data format which is widely used in the meteorological community. And of course, they're working on S-100 standards, but you might want to see weather data right now. And that you can do because this GRIP data are available widely. Other highlights here is we have any kind of geodetic calculations you want to do in this SDK. That includes coordinate reference systems, datum transformations, projections, calculation on spheroids, which might be useful if you want to know the length of a geodesic or the length of a loxodromic line and those calculations. And we have the EPSG geodetic dataset. Some of you may have heard of this thing, which defines coordinate reference systems used all over the world in a kind of database, and we have access to that. So you can, if you're interested in a special coordinate reference system, you just ask for this in the SDK by passing this EPSG code, which is just a number, to the SDK and getting a fully initialized object back. There's also algorithms on Cartesian geometry here. The typical elements we have here are lines, segments, circles, rectangles, ellipses, polygons, and those things, and we can do any kind of calculations. We have also a nice class here where you have polygons or even areas, which are polygons with having holes, and you can intersect this area with another area to get the area which is the intersection area, or the union, or even you can difference area, so which part of the area belongs to area E but not to area B. Those things we can do. Very nice class, very useful in many applications. So we use a modern technology for this SDK. So we're having the object-oriented programming paradigm chosen. So the actual programming language where this SDK is written in is C++. To be more precise, is C++11, which is a flavor of C++ or development of C++, which is also an ISO standard. And but we have also a wrapper, and the SDK can be used in the quite popular C# and .NET environment. And this SDK is available for Windows, from Windows 7 up to Windows 10, and also for Linux. One last thing I will to tell you about the SDK. We are SDK producers for more than 20 years now, and really what we learned from this is the handling of the maps. This causes problems everywhere. How we can import this, how we can do this functionality in our application. So this is always a headache for the clients. So that's why we choose now a concept of not giving that burden even to develop this part to the end user. So we give them a ready-made tool, something which comes with the SDK as a program, the chart installation tool. You see the little picture, and this is chart handling as the easiest way you can imagine. So you can just import a standard compliant exchange set into this tool. It actually stores this in a structure which can be used by the SDK later. So we have not to do anything later in the SDK with this. So when it's import the data with a very good performance, you can even import exchange sets which are in archives like zip files. You have not to extract them even on the hard disk, and it can read as exchange set also if they are encrypted, like the S63 exchange sets. So it handles all the permits also, and it gives you a list of the inventory of your actual chart library, and it gives you also a preview of each data set. You select in the list one data set, and it's automatically shown in the little chart image on the left upper corner of the application. You can even zoom and pan in this little window. It's not just giving you a picture. So it's really a live chart widget which you can use. So that makes chart handling really, really simple now. And I think that's the end of my application. If you now eager to know more about the Nautilus ECDIS Kernel SDK, you can follow this link to go to our website, find more information, or of course you can contact us and asking for more information. I thank you for listening to me, and I gave the microphone back to our moderator because I'm pretty sure that there will be some questions already having arisen.
Thanks a lot, Holger, for this interesting presentation and for the overview you gave us on the Nautilus SDK. Yes, you're right. We already received some interesting questions. And Friedhelm, maybe you want to pick some of these questions and provide some further details to the audience.
Yes, good morning and good afternoon, everybody. Friedhelm Morgert Kegler speaking. As a matter of fact, we've received quite a lot of questions. I will just pick up some of these questions which may be of interest for all the participants. Some of the questions we've already answered, but there's one question, I will read it out loud. How is the Nautilus different from the EC 2007, which is also 7C's product line? So the EC 2007 is the old traditional ECDIS kernel that's, I would say, still alive. The main difference is that, first of all, the programming interface is different. While Holger was pointing it out, Nautilus is using a programming interface based on C++, and there's a wrapper for C#. The EC 2007 still has an ANSI C interface. Also, due to all these extensions of S-100 compared to S-57 and the new S-100 data model, the sync format that is associated with EC 2007 is not really suitable for representation of S-100 data sets. I guess that, I hope, comprehensive answer. As we do every day, we will collect all the questions, we will publish the questions, and also provide comprehensive answers for all questions after the event. And I think we still have some time to highlight one of the questions that have come in. I don't know, Holger, if you picked up something, if not, there's maybe some other question I could answer.
Yes, I see one question here coming in. They say, could we manage real-time ships data, IIS position, path tracks data, maneuver prediction, voyage information using Nautilus for VTS systems? And the answer is yes, we will incorporate IIS parser, also NMEA, or sensor handling of other sensors into the next version of the SDK, which we preparing in the next year, and then you can get having direct information to those information with the help of the SDK. So the intention is to have those data, of course, available, especially IIS position and path tracks data might be also possible. Okay, let's see. Friedhelm has another question to answer.
Yes, indeed. There's a question similar to the one we answered before, also referring to Nautilus SDK and the data model. Is the data model for the Nautilus SDK still compatible with S-57? I think Holger mentioned it, that Nautilus will also support S-57. The internal sync format of Nautilus or the S-100 data model as such is capable of representing the S-57 data model as well. So in this respect, Nautilus is fully compatible with reading and handling S-57 data. There is one difference we pointed out yesterday already between with respect to feature attributes. While in S-57 we have so-called list attributes. So for example, color could have more than one value separated by a comma. For example, for cardinal buoys like 2, 6, 2. This is something that's not represented the same way in S-100, where we have where the multiplicity was introduced. But yes, Nautilus SDK is fully compatible with S57.
Okay, I have another question here. Let's ask here someone, can we also manage live weather data coming from external services? And I think the question is yes and no. We have in the SDK, no direct access to any live weather service, but if your applications do that part of the job and then getting the information in either the grip1 or grip2 format, then you can pass this files to the SDK and then having a high level access to different weather phenomena and can create overlays which you can then present in the application. So I think live weather data are possible. Also, part of the job has to be done in the application because we don't have no knowledge about how the live weather services actually works, and they may be different. So it's hard to do this in an SDK. I see Friedhelm has another.
Yes, another question. Can any GML file be used with the SDK? Yeah, the answer would be it depends. As I think that's my favorite answer, I figured. If the GML is used for data encapsulation of a specific S-100 compliant data product, the answer would be yes. But a general GML file that is not in line with the S-100 compliant data product is not supported out of the box by Nautilus. But still, since Nautilus is a software developer kit, which is extensible, and if there are special needs to support specific GML files, it's always possible to add extensions to this. But out of the box, Nautilus would just read such GML files that will be in line with the S-100 data model. Madonna, do we have more time for other questions? Then I would hand over again to Holger.
Yes, we have a couple of minutes left, and I can try to answer some more questions here. One question is, what version of .NET is the SDK wrapped in? And it is specific to Windows, e.g. .NET Standard or Linux. So the answer is that our C# implementation is specific to the .NET in Windows. So we support C# only for .NET Windows. So we have no experiences with using C# under Linux. Under Linux, we have the C++ version of the SDK only. Another question here is someone asked, we are also interested in 3D and mobile implementation. Okay, this is not so easy to answer, but I had yesterday we have talked about the model, and we see the question was if the model supports 3D. So first of all, the S-100 model does not support 3D objects. So you cannot do anything like a full 3D, like a video game. But of course, since the coordinates can be in 3 coordinate dimensions, it's possible to do some kind of pseudo 3D. So we can see depth information in 3D. We can also see gridded bathymetry in CD, which brings me to another question here, which someone asked if it's possible to display gridded data like from S-100? And the answer is not yet. But this is on our roadmap, and we will develop this for sure. S-102 is one of our highly demanded things to do in the SDK, and this is going to be developed very soon. And I just can see if there's more questions. I think there was one. It's a little bit difficult to go to that list here. Okay.
Maybe there's another one I could pick up here. There's a question, since Nautilus is a software developer kit which is used by developers. Are there any special skills such developers must have? I mean, I understand Nautilus is just not a tool to install and like an application, and then you operate it. You probably need some programming skills. That's something where you could specify some requirements on the programmers using the SDK.
Good question. And and since it is a software development kit which is will be used by programmers, programming skills, of course, are required, either C++ skills or C# skills, depending on what version of the SDK is chosen for the developing the application. So this is a necessary precondition, or someone should bring, or skill someone should bring to use the SDK. There's another question I've seen here, is that what is the actual IDEs we support for Windows? And I can tell you that we have versions for Visual Studio 2013, but also for Visual Studio 2017, both for 32 bits and 64 bits. And on the Linux side, we don't support any specific IDE system there, but we support different Linux flavors, or what do you call them? So we have a version ready to use on the Ubuntu Linux, and we have also a version on OpenSUSE. Which versions this exactly are, you can find on the internet page. But these are usually the long-time stable versions. And I see that Friedhelm has also something to say.
Yes, I've picked up another question referring to the eGlobe ECDIS, which is a product of our mother or sister company, or actually it's one. It feels like one company, Chartworld. And the question is, does this mean that the eGlobe ECDIS now will be able to read and display S-100 data? That's the plan on the long term, but as the S-100 support is based on our Nautilus kernel, and Nautilus is the core basically of all the new applications we are developing. This is also true for the eGlobe ECDIS, so which means first we need, of course, to integrate Nautilus or do a full integration of Nautilus in eGlobe. eGlobe already contains some components which are, I think, more related to, I guess, projection and geodetic topics, actually something we talked about today. But with respect to chart display, eGlobe is not using Nautilus yet, but that's something that will come in the next year. Do we have time for another question? Yes, everybody says yes, we can take another question. Holger, go ahead.
Yeah, actually 2 questions are here, and I think that will be then the end of our session here. So it's one question is support provided for virtual machines by the SDK? And the answer is yes. this SDK can run in virtual machines. We're using a different data or a software protection mechanism now, which it's called we're using software from a company called Vibu, and this runs for very nice on virtual machines. And the second question is the licensing model from the SDK different to the EC 2007 kernel, and the answer is slightly different. So in general, we have also this model concept, but we have larger modules you can choose from, and there's still a module with only access to Cenk data, and then we have other modules for ECS implementation, ECDIS implementation, military implementation. So we have this slightly different module structure, but in general, we still have a module structure. So that's why slightly different, not really exactly the same. But to find out more, please contact our sales department. They will happy to provide you with any information. And then I say goodbye, thank you, but for the last words, hand over back to Stefan, our moderator.
Thank you, Holger, and thanks for your very nice and interesting questions. I think most of them had been answered during the session. As said several times, you will receive the questions and the answers by email later on. So we're at the end for today, and I hope you found it useful and interesting. I would like to thank you for your patience to stay with us all the time. As already mentioned, the webinar had been recorded and will be shared to you via our YouTube channel soon. I hope you will also join our last part of our S-100 camp tomorrow, where we would like to share some news with you on our ENC production tools. The focus will be on the introduction of a brand new S-100 compatible software solutions. So thanks a lot for attending this session and have a nice rest of the day. See you soon.